my end.
All right, so my name is Patience Ansong, and I'll be taking you for Physiology 1. Okay, please give me a minute. Let me share my screen so that I can appreciate it. Okay, so I'll be taking you for Physiology 1, and I should be expecting more than 100 students in the class. So I'm assuming a lot of you are late, but you are aware you have class at 3. So as we move on, I'll let you know some of the rules for my class. I don't know of others, but I always have rules for my class. And before that, I prefer class reps for the various centers. You introduce yourselves for us to know you, so that if I'm to communicate anything with the class, I will know where and when to do that. So let me see the class rep for Kumasi Center. Kumasi Center. Class rep for Kumasi Center.
I'm here, madam, I'm here.
Yes, please introduce yourself.
Please, my name is Godfred Kwame Bwedi.
Godfred.
Yes, please.
Okay, okay.
Godfred Center.
Okay. So do you have any assistants for your lead person?
No, please. I have my assistant. He's Richard Safo.
Yeah,
Safo
so
Richard.
let him introduce himself.
Ma'am, I'm Richmond Safo.
Okay.
Boss for Kumasi campus.
Okay, all right. Nice to meet you, Kumasi Center course reps. Godfred and then Richard, right?
Yes, please.
Okay. All right, then let's see the course reps for Tamale. Tamale.
Hello.
Yes.
Yes, please. My name is Dinusat Mogdul.
Come again.
My name is Dinusat Mogdul.
Okay, Dinusat. Okay.
Please.
Yes. Okay. Any assistants? Any assistants?
Please, no for now.
Okay. All right. So let's see course rep for WA.
I'm here, madam.
Yes.
Yeah. My name is Kaleuna Mumen.
Okay.
Yeah.
No assistants?
Not yet, please.
All right. Okay. Then let's move to Oporidia. 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 Or no students coming from Oporidia this time?
Sister, I'm here.
Yes, yes.
I'm Alberta, but I think our course rep is not around.
Okay. So, okay, all right, that's fine. And then let's see Akimoda. Akimoda.
Please, I'm here. Perfect, Jakbasu.
Perfect. Okay. Okay. Nice to meet you. Perfect. Let's see. Taprade. Taprade. No course rep for Taprade. No course rep for Taprade.
Sister, we have, but I don't think they are around now. We have course reps. We have one and assistant.
It's too early to absent yourself. It's too early. I know you've heard a lot about me from the other classes. I'm so sure you've heard a lot. But let's let's be mindful that we are here to learn. Okay, you have paid fees and you want to gain something after that. So I don't entertain absenteeism in my class. Okay, so please inform them. As a class rep, you should be the first person in the class. Okay, let's see reps from Ansong.
All right.
Ansong.
Yeah, please, I'm the assist.
Assist, okay. Where is your main?
I think it's busy somewhere, but we are not together.
Yes.
We stay in different places.
But you don't know why he's not here.
Yes, please.
Okay. All right. So can you introduce yourself?
I'm Sam Ebenezer.
Okay, Ebenezer. Okay. Nice to meet you. All right. Any other center I've not mentioned?
Yes.
Yes, please.
Madam.
Okay, which center?
Kita.
Yes, Kita. Yes, Kita. Classroom.
I'm Solomon Akapusu.
Solomon. Okay. Nice to meet you, Solomon. Aside Kita, any other center? Okay. All right. So you are all welcome once again. As I said, my name is Patience Ansong, and I'll be taking you for Physiology 1. And the course code is lesson 307. Lesson 307. It's a 2 credit hour paper, and you will have 2 contact hours for every week. So on the timetable, I'm supposed to meet you on Sunday. It's supposed to be in the morning, I think 9:15 to 11:15. But I communicated to some of the class reps that time is not favorable and therefore we have to reschedule. So they came back to you guys, and then I think the time they gave me is 11:45, right? Godfrey, 11:45.
Yes, please.
It was
Yes.
one.
Come
It was
again?
one. It was 1:30.
Not 11:45.
Yes, please. It was 1:30.
Okay, so we'll meet from 1:30 to that would be 3:30, right? 2
Yes,
hours.
ma'am. Yes.
Okay, that's fine. Okay, that's fine. Okay. So today we're supposed to meet and introduce ourselves last Sunday, but since we didn't do that, you'll do that today and then continue with lectures because we have to speed up. Yes. So just like how we have rules for everything, definitely there are some rules that governs physiology class. So the first one, of which is common to you as students, is to attend all classes. Attend all classes. So my classes are very flexible. Okay, I know CODeL, you are busy here and there. Some of you didn't, it's not a steady deal. Okay, so you are doing that alongside working. So it's somehow flexible. But I expect that every time there's a class, you should join. You should be in class. Okay. So after the class, normally what I do is I share the slides with you, and depending on the attitude of the class, okay, depending on the attitude of the class, I also share the video or the recording of the class. Okay, so depending on that, I also share that resource. Then aside that, we are also going to, so basically that's that. So for most of the classes, I'll be taking attendance. to just cross-check those who will be joining the class on time and those who just join in and leave just to pick up the record of being in class. So that's that for the attendance. And you have to be on time. And for physiology, I'm sure with a fair idea you have from your background during your diploma levels, you did anatomy and physiology, and therefore you have a fair idea of what physiology is about. And I'm expecting you to read constantly because physiology is the basis of medical sciences. And I wouldn't say it's difficult, but if you don't sit up, it's going to be challenging for you. Okay, so with anatomy, we always advise you sit up and then you read constantly. So I make sure that you have the resources needed. All you have to do is to sit up instead. And since I'm making provision for all these, if at the end you don't try your best to reach the mark, definitely you are going to fail or fail. And I know that will be stressful because you come back and read all that you have done again to write another paper. So I always advise my students to sit up once and for all, pass, and then that's it. Okay. So in the class too, you listen and then analyze. You listen and analyze. So as I'm teaching, you listen carefully, you analyze, you share your thoughts on that, and then you also ask questions if there need be. My class is very interactive. It's not a dictative class. So as at when we are having a class, we answer questions, we share ideas on topics and all that. So I'm not the only person going to talk. We are all going to talk, okay? And I expect that all your microphones will be muted for an effective class. So when you have a question or an idea to share, you put up your hand, then we call you out, and then you answer or you talk. So until that, your microphones are supposed to be muted, okay, so that we have an effective class. Any concerns on the rules? You want to add some are not comfortable for you, you want to suggest something, or you want to reproach any of them, the floor is open. Okay, so that means we are all on the same page. So with physiology, okay, so let's start the class. Now, Portia.
Sister.
Yes, so what do you know about physiology? This is not the first time we are hearing it, so what comes to mind when you hear physiology? Okay, so Juliana assist Portia. Juliana Juma Segwa, right?
Okay. Yes, please.
Yes.
So physiology is how the body structures function.
How the body structures function. I'll give you 8 out of 10. Well done. 8 out of 10.
Okay.
Yes. So yes. So just like how most of you have done, please identify yourselves with your name and your index numbers. Your name and your index numbers. You can see some with only their names, some with only their index numbers. Please add the two. Bismarck Asari. Bismarck. Bismarck. Bismarck is not in class.
Hello. Hello.
Yes, Bismarck, yes. Hello, Bismarck.
Hello.
Yeah, we are listening to you.
Oh, okay. Physiology is the study of the functions of the various parts of the body.
Function of the various parts of the body is the same as what Juliana said, so 8 out of 10. Let me take the last submission, then we continue. Yes, Samuel, Jay.
So, it's a branch of biology that deals with normal function of a living organism and its their parts.
Yes, 10 out of 10. Yes, that's it. So with physiology, when you are talking of the functioning of a living organism or parts of a living organism, you are looking at the normal functioning. Okay, so normal underlying. So you can't just say you are looking at the functions of the parts. You want to look at in their normal state, how they function. I hope that is clear. All right, so with physiology 1, we are basically going to introduce physiology, basically build upon the little you know from your diploma. So you look at intro to physiology, level of organization of the human body, body fluids, transport mechanisms, and cell reproduction. Then, cell physiology 1, look at tissues and tissue function, homeostasis. Then we start with the systems, so the skeletal system, then we move to muscles, we move to the cardiovascular, we move to the lymphatic, respiratory, nervous. So we are going to look at all the systems that make up the human body. At the end of our study, we should be able to identify the main body fluid compartments and estimate their volumes. We need to be able to describe the structure and components of plasma membrane and basically what the cardiovascular system entails. And here we're also looking at how the plasma membrane, the cells, parts of the cells, we are looking at how transport is done in and out of the cell. Okay, then we look at homeostasis. Then after homeostasis, we look at signal transduction mechanisms and so on. Then we move to the nervous system, where we are going to look at the subdivisions of the nervous system, the cells that make up the nervous system, their functions. Then we look at how information is transmitted within the neuron or the nerve cell. Then we also look at how we can explain or better understand resting membrane potential and then action potential. Then we also look at some stimulus and then their strength and how the nervous system differentiates them. Then as we move on, you look at the different types of muscles, excitation, coupling reactions, look at the sliding filaments on how contraction occurs in the skeletal muscle cell. Then we also look at postsynaptic, presynaptic potentials. We also look at transmission along the neuron through action potential, and so on. We also look at neuromuscular transmission, that's the transmission of an impulse from a neuron to a muscle. Don't worry if you are confused, just our learning objectives, you are going to pick them one after the other. So all these are expected of you at the end to be able to comprehend and then produce it at the end of the semester. So the study objectives, we have a syllabus, and basically that's what I'm giving you a fair idea about. Introductory, then you look at the systems one after the other. Then we introduce each of the systems at the beginning of every topic, or we introduce the introductory parts at the beginning of each system. So based on the level of organization that we have the cells, the tissues, the organ systems, and then the organisms. Mainly physiology, we are going to look at the systems. But before we talk about the system, we'll go back and look at the cells that are found in the tissues that are found in the what they do. And as I said, we are going to have an interactive sessions. With assessing ourselves, first of all, we have a continuous assessment, 30%, and then we also have end of semester examination, which is 70%. With continuous assessment, we will have midsem, and midsem mainly it will be 50 marks. Then we have online quizzes that will form 10 marks of the continuous assessment, and I'll take attendance twice in the semester, and that will also form 10 marks of the continuous assessment. So with the quizzes, it will be impromptu. You wouldn't know the day you are doing the quiz. With the roll call as well, I wouldn't let you know when I'm taking the roll call. So I can decide to do that any day. For the midterm, there will be a scheduled time that you know of before you write it. These are recommended books that you can take a look at if you want to read further. And of course, you have to read further. The slides that I'll be giving you, they are just in points, okay? So you have to find further explanations to that. So as I'm teaching, you can take notes, and then aside that you can look for these books to better explain the points. And then you can also get videos on each of the topics to better explain and for you to better understand. Any questions? Samuel, your hand is still up. Do you have a question? Yes, Ebenezer.
Madam, I just want to suggest something about the unannounced quiz. You know, most of us, we have network challenges, and in fact, if the quizzes are going to be unannounced, it is going to affect. Hello, madam. Hello.
Yes. Come again.
Yeah, please, I'm talking about the quiz. Is it the quizzes can be unannounced?
Yeah.
So what I was suggesting is that if it goes that way, it is actually going to have a great effect on us, because most of us, we are having network challenges. So if it goes that way, meaning most of us, we can't even join. Besides, sometimes we may be at work. So if the quizzes are going to be announced, I think it wouldn't help us. So please, if you can reschedule the unannounced that thing for us. But you are cute.
Thank you. So Ebenezer, as for the quizzes, I can't schedule them. Yes, I know you are busy, but at the normal instance, you're supposed to take a leave before you study, right? Yes, but I know a lot of you are not in that situation or position. So the quizzes are conducted when we come to class. Okay, and I'm sure you make time to come to class. So suppose you are in class, definitely you take part of the quiz, unless you don't want to attend class. Okay, and with the network, definitely I'll give room for that as well. So there will be instances where some will complain, my network, that. As when it gets there, I'll know what to do. Okay, but quizzes can't be scheduled.
Okay.
All right. Any other submission or idea questions? All right, so let's continue.
Yes, please.
There's a question?
Yeah, please. Concerning the time, I think our course rep earlier said our
Please, who
time
is this? Who is talking?
is this Apia Emmanuel.
So appear Emmanuel, kindly re-identify yourself with your name and index number after the class, okay?
Okay, please. Okay, please.
Yes. You
Please,
can speak.
concerning the time, I think our course rep, Godfred, earlier said the time has been rescheduled to 1:30 to 3:30. Yeah,
Okay.
but the time our anatomy master also made it said to us that his time he will be shifting it to 1:30. So I don't know how those two courses will be done at the same time. That's my worry, because he earlier said that his time is not favorable, so he has shifted his own to 1:30. And Godfred also mentioned that 1:30 to 3:30. So it's like two courses at that same time.
Hello, sister. Can I talk, please?
Wait, so please, concerning the time arrangement, you should organize yourself as a class. So the decision shouldn't come from only the classroom. Okay, so as a whole class, please find a convenient time for us to meet. Okay. Anatomy, I don't know, anatomy on the normal timetable, you're supposed to have it right after mine. So just talk to him the time he wants to fix his phone, and then as a class, to the time that you be ready for me. The reason why I'm being flexible, I don't want to fix any time for you, is I want you to join the class always. So you bring your time, the time that will be convenient for you, then I make time for it. But the morning, Sunday morning is not favorable for me. Sunday morning is not good for me.
Okay.
Yeah. That's all. Should we continue?
Yes, please.
Okay, so physiology. I think we've answered this question already. What's the difference between physiology and anatomy? Godfred, Lashred. What's the difference between physiology and anatomy? Godfred.
Hello, madam.
Yes.
Anatomy has to do with the functions, the body part itself. And then physiology is how they work hand in hand to ensure the well-being of the whole body. Thank you.
Well said. That's correct. So with anatomy, we are going to look at the study of the body parts. Okay, body parts. So you just look at the parts of the body. But with physiology, we are looking at the normal function of these parts. Basically, that's the difference. Please take note. So physiology, as we said, we are looking at the study of how living organisms function. So in general physiology, we are looking at how the living organisms function. So living organisms, we can have animals, plants, and other organisms. So it's a broad science which aims to understand the mechanisms of living, from molecular to cell to the whole body. So as we move on, we are going to get to know how living organisms live, how the parts of the body functions together integratively to make you as an individual live in a healthy state. Okay, so we are going to take that from the cellular level within the cell. what actually happens. So we get to the tissue, we get to the organs, and then the system, and then the whole body as an entity. Then we are also going to explain the physical and chemical mechanisms responsible for the origin, development, and progression of life. Chemistry will take some parts, and then I'll also do that. I'll also take some parts. I mean biochemistry. So ultimately, we are saying physiology answers the question why. Why is this happening in your system? Why is that happening? And it also answer the question how does it happen? Okay, so how does digestion occur? And why is it that at the end of digestion, you get the end product in your blood, and for your blood to transport the cells? How does that happen? And then why? Why are you even breathing? Okay, what's the essence of breathing? Okay, and how does the body get in oxygen to every cell? So basically, physiology, we are answering the questions why and how. Okay. So we are saying each life form, from the simplest virus to a complicated human, has its own functional characteristics. So that will give us different categories of physiology, or different categories of how these organs, these life forms function. So looking at that, you can have branches of physiology. You can talk of viral physiology, bacterial physiology, plant physiology, human physiology, etc. So because of our profession, our career goal, or where we want to go, we are going to emphasize on human physiology, only human physiology. So whenever you are asked a question in this class, your answer should be tailored to human studies. So viral physiology is just looking at how virus function, bacteria, how bacteria functions, plant, how plant parts function. So emphasis will be on human physiology. Now back to the class. Confidence, capacity.
Yes, sister.
Yes, so just from the brief intro we have done, how do you understand human physiology?
Sister, please, you said it's the branch of biology which studies the normal functioning of the parts of the human body.
Yes, excellent. So we are basically going to look at the normal functioning of the parts of the human body. So anatomy, human anatomy is focusing on studying the parts of the human body. Physiology, we are emphasizing on the normal functioning of the parts of the human body. So it allows us to explore how the human body functions at all organizational levels. And to move on, we'll get to know these organizational levels. So we also have research, a lot of research ongoing in different branches of human physiology that is answering a lot of questions in the scientific world. Okay, so day in and day out, there are new research and new discoveries done in the field of physiology that is helping us explore, understand, and better improve the quality of our lives. Okay, and some also helps at the end in developing medicines, therapies, and interventions to help reduce illnesses, infections, and so on. Okay, so you're also saying that as a nurse, as a doctor, midwife, or any healthcare provider, you need this study in human physiology to be able to attend to patients and treat diseases. Because first of all, if you don't know how a part of the body functions normally, how then do you explain if something is abnormal? Okay, so that's why we are doing human physiology in the first semester, because you need to know the normal functioning of the body before you build up to study diseases and illnesses. So looking at specialties in human physiology, or we are also branching from human physiology to a lot of categories. We started with the general physiology. We had branches, viral, bacteria, human, and animal, and so on. Now I want to pick human physiology and also branch into human physiology. Now, from what we have been saying since the beginning of the class, can someone tell me the level of organization of the human body? Patients, patients, what are the level of organization of the human body? Patients. Patients. Absent.
Hello.
Yes, patients.
Hello. Please, we have the cells, the tissues, organelles, and then like this one.
That's all.
Hello. And we have the cells, tissues, organs, and the organ systems. That makes the level of organization.
Okay. And the last one is organism. Okay. So the organism is also part. So when you look at the level of organizations, we have cells. Now, a lot of similar cells with performing a similar function would come together to form a tissue. Now we have a lot of tissues coming together, similar tissues, and then performing a similar function, coming together to form an organ. Then we have different organs also performing a particular function, coming together to form a system. Then we have all systems of the body coming together to form the organism. So that is the level of organization of the human body. Now, if you take that, can you hear me, class? Some are saying they can't hear me.
Okay, we can hear. Some of us can hear.
Can hear you.
So please, those who can't hear, kindly check your network. You can log in and come in again. You can log out and come in again. All right. So depending or based on this level of organization that you mentioned, you can have specialties in them. Okay. So probably maybe after your BSc, after working for a while, you can decide to do your master's. That's if you want to come into the academia. So if you want to do your master's, you have to do a research. And if you choose to do master's in human physiology, then you need to branch into one of these categories. Okay, so you can look at the cell physiology. You are looking at the study of the cell. So you look at the functions of the parts of the cell and what actually happens within the cell. With a cell, you can take a specific cell. Okay, you can take a specific cell. You can take the neuron, okay, found in the nervous system. You can say you are narrowing all your studies into the study of the neuron, looking at how it functions. Okay, then you can also look at tissue physiology. With the tissue physiology, you can look at epithelial tissues, connective tissues, so you can branch into any of these tissues and study them. Then you look at the organs, so any of the organs of the body, you can decide to pick it and look at how it functions. We have a lot of research ongoing in any of these levels that is making new discoveries, that is helping in the health sciences. Then you also look at the system, so the systemic physiology. You pick a particular system, you study about how it functions. Then you can also, aside this level of organizations, you can have other branches. For example, exercise physiology. We are basically going to look at how the system, taken from the different level of organizations, come together or help make exercise, and also how exercise influences the normal functioning of the body parts. So when you are doing biochemistry, you take the level of organization from the chemical level, that's the atoms. Then 2 or more atoms will come together to form a molecule. Now, with physiology, our main emphasis, we start from the cellular level, as patients did. So we start from the cell level. So a lot of similar cells performing a particular function will give us a tissue. Coming together will give us a tissue. Then we have tissues that will coming together to give us an organ. Then a lot of organs will come together to form a system. Then a lot of systems or all systems will form an organism. So the chemical level we are saying is biochemistry, made of atoms, the smallest unit of matter. And we are saying a lot of them will come together to form a molecule. Now, we'll start with the cellular level. Any questions at this point? Any questions from the class? All right. So we look at the cellular level. That's the first one. So you are saying from your diploma studies, you learned about the cell. Okay. And you said the cell is the basic functional unit of life. Can someone explain this? The cell is the basic functional unit of life. How do you understand this? Joyce Asante. Joyce. Yes, how do you understand cell being the basic functional unit of life?
Okay, from my understanding, there can't be any organ or organism without the cells. Since the cells come together to form the tissues, then the organs and organ systems. So without the cells, there's no tissues and organs, and there wouldn't be any individual.
Okay, well said. So you've explained the basic part. So we also added that is the functional. So the basic functional. How do you understand the functional part? Solomon Farm.
Okay, madam, please, talking about the cells, we have specific type of cells like the nerve cell, the muscle cell. So the muscle cell and the nerve cell have their specific function. So the nerve cell it transmits nerve impulses. So I think that's one aspect of the cell being functional. Thank you.
All right, thank you, Solomon. Thank you. Okay, so aside that, can someone add something to the functional parts? The basic functional unit of life. Anyone? 1 plus. Who are you? So please, for our next class, kindly identify yourself with your name and then your index number. 1 plus 5. Who are you?
Hello, madam.
Yes, 1 plus 5. Yes.
Please, I'm Rosalante. I'll correct it after the answer.
All right. Okay.
Please, what I understand by the basic functional unit is, I understand it to be the basic or the simplest living functional unit. The simplest.
Okay.
Is the simplest living functional unit of an organism.
Functional unit.
Yeah, the simplest
you are basically
function.
saying the same thing. You are saying the same
Okay.
thing. Yes, you are saying the same thing. I'm saying it's the basic functional unit. You are just repeating the same thing.
Okay, madam, is the simplest living working unit of the cell of an organism.
Okay, that's fine. Yes, Daniel.
Hello, madam.
Yes.
What, to my understanding, what it means is that any activity or any anything that will happen within the organism to make up the organism will basically start from the cell.
Perfect.
And hence it is the building block, and then it is alive. It is moving.
Yeah, that is it. So just the first statement you made. So when you pick a tissue, an organ, a system, okay, the cell is where the actual work is done, or that's the level where the function of the entity starts from. You get it? So you're saying that is the basic functional unit. Basic meaning, yes, is the cell makes up the tissue and so on. That is the basic. So that is the basic unit. But when you talk of basic functional, you are saying when you pick, for example, an organ, let's say a stomach. So before a stomach can contract to move food from the stomach to the small intestines, that movement is initiated in the cell, or that movement starts at the cellular level before it comes to the tissue level. I hope you are here. You get it? So the function is starting from the cell. So when you pick a cell, physiology, we are trying to look at how functions happen within the cell. Okay, how functions happen within the cell before we come to how it comes together to also make the tissue work before the organ as a whole, and then the system as a whole. I hope that is clear. All right. Then we are saying that is where all life processes take place. All life processes take place. Okay. So with the cell, from diploma, I'll still make reference to your diploma level. We learned a lot about the structure of the cell. So the first one that we want to look at is the generalized cell. Generalized cell, and that's what we mostly talked about. Generalized cell. So with a generalized cell, you would have a cell membrane, which is the yellow lining holding the content of the cell. So that is the cell membrane or the plasma membrane. So the cell membrane or the plasma membrane is there to hold the cell in place. As you all know from our basis, we know that inside of the cell, we have the fluid parts. The fluid part. The fluid part is called the cytosol. The cytosol. So this cell membrane holds the cell in place so that the cytosol doesn't flow out, and we also have this solid substances in there, not leaving the cell. Aside that, we also have some proteins that is fixed in the cell membrane that helps move substances to and or in and out of the cell. Okay, so as we move on, we are going to look at transport mechanisms. How at the end of digestion, you have glucose getting into the blood. Then when you have a lot of glucose in the blood, we are saying you store some in, for example, a skeletal muscle cell. How does the excess glucose move from the outside to the inside of the cell for storage? We are basically going to look at how ions are moved from the inside to the outside of the cell. How some proteins, some substances that the cell needs for production moves into the cell. Then we're also going to look at basically So when you look at the solid substances that you see here, we are saying they are organelles. And from your basis, I'm sure you know a lot of them. We have the Golgi complex, the ribosomes, the endoplasmic reticulum, smooth and rough. We have the nucleus, and then we have mitochondria, we have the lysosomes, we have vesicles, and so on. So all these are found inside the cell. You also have some filaments, some proteins that is also found inside the cell. Now, so basically that's the structure of a generalized cell. Generalized meaning basically when you have to take the whole body, the basic structure of the cell is in this way. Okay. Then we also look at specialized cells. So I normally do something with the regular students. We take class assessment after each class. So I forgot to alert you. So after each class, for example, after today's class, we take assessment. Maximum 10 students randomly. I pick you, then you answer questions on what you've done for the day. Sorry, I'm telling you now. Okay. I hope that's fair.
Yes, madam.
Yes. I just want you guys to be here every time. You have to be here, attentive. Okay. All right, so specialized cells. So within the body, we are saying we have some cells that are specialized from their name. They are specialized because one, their structure is not like a generalized cell. Two, they are performing a specific function. Aside that function, they can't perform any other. The common one that you know of is the red blood cells. The one down there, the red blood cells. So look at the shape of the red blood cells. It's not like the generalized cell. We have the hollow center, okay? And that hollow center enables the red blood cells to perform a particular function. And the function of red blood cells, okay, so what's the function of red blood cells from your basic studies? Abbas, Abubakar, yes, Abbas. The function of red blood cells. Abbas, Abubakar. Absent. He has left the phone and he's doing something else. Abbas, Abubakar. Okay. Is it Achio Joyce? Achio Joyce.
Yes, madam, please.
Yes, what's the function of red blood cells?
Carry oxygen.
Come again. Hello? Hello? Class, can you hear me?
Yes, madam.
Yes.
I think I try something.
Hello, madam.
Okay. Yes, Joyce.
Hello, madam, please. Sorry.
Yes.
The red blood cells carry oxygen from the lungs and deliver it throughout our body.
Yes. So the red blood cells basically transport oxygen to all parts of the body. So the center is made in such a way that it increases the surface area for oxygen to bind to hemoglobin. Okay. And aside that, we can also see that the cells are red in color and they have specialized molecules called hemoglobin that enables them to perform this function. Aside that, the red blood cells, they don't have any organelles within the cell. And that also makes them unique and enables them to perform their function. So red blood cells are specialized cells. Then we have white blood cells. So example of white blood cells, we have neutrophils, we have lymphocytes, we have basophils, eosinophils, all these are there. They are specialized because they don't look like a generalized cell and they are performing a particular function. Now, for example, this white blood cell, you can see that we have these yellow molecules and they are there to attack foreign invaders or pathogens. So whenever there's any foreign invader coming into the body, these molecules are released to attack the pathogen or that particular invader. Okay, and you can also look at the structure of the white blood cell, as it's not like a generalized cell. We have logos inside, some loops. Okay, that is unique to it. Then we have this one as well. This is a neuron. A neuron is also known as the nerve cell. The nerve cell. The nerve cell is found in the nervous system, and that is the cell that transmits impulses. Okay, so impulses, you are just transmitting information to and fro within the body. So whenever I say electrical impulse, I'm talking of information transmission. So this neuron is specialized in such a way that it can pick up an information or an electrical impulse from one part of the body and send it to another part. For example, the little you did during diploma, you did the reflex action. When you step on a nail, you immediately pull up your leg, and it's the function of the neurons or the nerve cells under your feet to sense the change, and then that information is transmitted to the brain for interpretation, still using the neurons or nerve cells, and then information is interpreted, and then we have response coming back to your feet to pull up your leg. So basically, it's only the neurons that transmit impulses, okay? And we are still talking about the cellular level. That's why I'm mentioning the nerve or the nerve cell or the neuron. Now, with the neuron, you can see the branch-like structures. Those are the dendrites. The dendrites receive the information or picks up the information transmitted to the cell body. The cell body is where we have the nucleus and other organelles. Then the cell body also transmits the information or electrical impulse to the axon. Now the axon also transmits the impulse to the axon terminal, where it passes the information to another neuron. As we move on, we get to the nervous system and we'll learn details of this. Then we also look at some specialized cells under the muscle cells. So under muscle cells, we can have skeletal muscle cell, smooth muscle cell, and then cardiac muscle cell. Whenever you hear cardiac in our study from now on, you are referring to the heart. So cardiac muscle cell is the cells that form the tissues of the heart. Then we have smooth muscle cells also forming smooth muscle tissues that make up most of the hollow organs. Then we also have skeletal muscle cells that mainly form the skeletal muscle tissue that is attached to the skeleton or the bones. So we can see that they are somehow elongated compared to the generalized cell. So their structure is unique. And basically, what these muscle cells function is contraction. So they contract to enable an activity to occur. We'll move deeper into that as we move on. Then we also have this specialized cell called the intestinal epithelial cell. Looking at the structure, we have some unique structures such as the microvilli that enables easy absorption of end products of digestion into the cell. Okay, so this microvilli is there to help easy absorption of nutrients into the cell, and then henceforth out of the cell into the blood. Now we look at the tissue level. Now we are saying a tissue is a group of similar or related cells that will work together to perform a particular function. And you can have 4 types: epithelial, connective, nervous, and muscle tissue. Epithelial tissue, connective tissue, nervous tissue, and then muscle tissue. With epithelial tissue, we are saying it covers body surfaces. It lines hollow organs and cavities, and it constitutes most glands in the body. And you have types. We have types of this epithelial tissue. Now we look at 2 main categories of the epithelial tissue. Number 1, we are categorizing them based on the shape of the cells in there. The shape of the cells in there. Number 2, we are categorizing them based on the number of layers of the cells in there. Okay. So based on the shapes of the cells in there, we can have squamous epithelial tissue, we can have cuboidal, we can have columnar. So these 3 have different shapes and sizes of the cell that make up the tissue. And then based on the number of layers, you can have simple, you can have stratified. Simple from the name is just 1 layer. Stratified is multi-layered or more than 1. So using a picture to better explain, we are saying simple squamous, or let's take the shape first of all. So let's look at only squamous. So all epithelial cells that are squamous are flat, as you can see. They are flat. So you have their breadth longer than their width, as you can see. So they are in that flat shape. The cuboidal, their width and breadth is somehow similar, as you can see here. And then the columnar, they have their width longer than their breadth. Then we can also say, so we are saying all these are simple because they are one layered tissue. So just one layer. So they are all simple. But the difference comes in with the shape of the cells. Squamous here, like cuboidal, looking like a square, and then columnar also having a longer than the breadth. Then we also look at the layers. Okay, so stratified, meaning you have more than 1 layer. So you can see 1, 2, 3, 4, 5, 6. This is 6-layered epithelial tissue, and therefore we term it as stratified. And you can see that the cells here are flat, and that's why we say they are squamous. So this is stratified squamous epithelial tissue. Then we also say that you can have other classification. So we can also have stratified columnar, stratified cuboidal. Okay, so this is just a representation of the multi-layer. Then you can have another category called transitional. Transitional epithelial tissue, most of the times from the name, transitions or changes. Okay, it transitions or changes. So here, most of the times, the main example I can use is the epithelial tissue lining urinary bladder. So whenever you have a distinct urinary bladder, you tend to have all the layers showing that way. But whenever it's distinct, the layers stack against each other such that it can give you a wrong report on the number of layers. Okay, but whenever after urinating the epithelial tissue comes back to its normal shape, you see the normal number of layers that we have in there. Then we have pseudostratified. Pseudostratified, we are saying that pseudo is false. Stratified is giving us is giving us false number of layers. Looking at this picture, for example, you can see that you might think the layers here is 2, meanwhile it's 1. So since the inside of the cell is fluid, we can have the nucleus moving to the upper part. You can have the nucleus moving to the lower part. And this is based on how combining or stacked the cells are. So depending on how they are stacked together, you can have these cells, some of their nucleus pushing up, some pushing down. And that will give you a false indication of their layers. So this one is just one layer, just that we have some of the nucleus moving, some of the cell, the nucleus of the cells moving up, some also down. Then you have connective tissues. So with connective tissues, we are saying, okay, any questions up to this point? Any questions up to this point? Yes, some.
Yeah, please, with the shape of the red blood cell.
Yeah.
That halo-like shape on it, you said its function was what? Is it for oxygen, how do you call it? Oxygen attachment or what? I did not hear that part well.
Okay, you said which part? The hollow center?
Yes, please.
The hollow center just gives room for a lot of oxygen to bind to hemoglobin. Now, the whole red blood cell, it doesn't contain any organelles. So within it, we have a molecule called hemoglobin, a lot of them. Okay, so what this hemoglobin does is it picks up oxygen. So it increases the surface area. That shape increases the surface area for a lot of hemoglobin to bind to oxygen. I hope that is clear.
Yes, please. Thank you very much.
You're welcome. Gifty. Gifty is down. Gifty Kinaman. Wow. Is it Costina? Costina, your network is very bad. Can you type your question in the chat box so that we address it? Okay, Gifty, your hand is still up. All right, so if that's all, we continue. So with connective tissue, that's the second tissue we are talking about. Connective tissue is not like epithelial tissue stuck together, okay? With connective tissue, still we have cells in there coming together to form the tissue. But here the cells are separated by extracellular matrix. This extracellular matrix is basically fluid form, and it's made of proteins, fibers, some bound substances, and so on. So with connective tissue, we don't have the cells coming together or stuck together like the epithelial tissue. However, we have the extracellular matrix surrounding the cells. The common example of connective tissue is the blood. So we know that the blood is made of red blood cells, white blood cells, and platelets. Okay, so these cells are found inside the blood, and the cells are not stuck together like epithelial tissue. You have the fluid part of the blood, which is called the plasma. Okay, the plasma contains proteins, hormones, and other secretions, and so on. Okay, so we have this plasma surrounding the cells, and that makes blood the connective tissue. We are saying connective tissue consists of cells that are separated by abundant extracellular matrix. Okay, and we are also saying that we have an exception, that is adipocytes, fat cells. So these fat cells are exempted from this category. And I made mention that we can categorize blood as a connective tissue, We can also talk of bone, cartilages. So as we move on, we better explain their components and what they do. Then we are saying that connective tissue functions to bind organs, support, protect, help in movement, storage, heat production, and transport. So the one I mentioned, which is blood, we are saying it helps transport oxygen, molecules, other substances each cell in the body needs to all parts of the body. Then we look at muscle tissue, the third one, muscle tissue. So muscle tissue, we are saying they are elongated. I showed you the cells that make up the muscle here. So you can see that they are elongated, okay? So the skeletal muscle cells will come together to form the skeletal muscle tissue. The smooth muscle cells will come together to form the smooth muscle tissue. The cardiac muscle cells will come together to form the cardiac muscle tissue. Now, we are saying their main function is to respond to stimulation by contraction. You have this contraction as a whole topic to do. Then we are also saying that the muscle tissue helps in body and limbs movement. So which muscle tissue helps in body and limbs movements?
Muscles.
Which muscle tissue helps in body and limbs movements?
Skeletal muscle.
Skeletal muscle.
Skeletal muscle.
Yes, skeletal muscle. So skeletal muscles are attached to the skeleton or bones, and that helps in movement of the limbs in the body. Which muscle tissue also helps in the process of digestion and waste elimination?
Muscle.
Yes.
Epithelial muscle.
So please, when you know the answer, kindly put up your hand and let's make it very, let's organize the classroom. Yes, after reading.
Is the smooth muscle?
Yes, the smooth muscle. So the smooth muscle is mainly involved in the process of digestion and so on. Then breathing and speech. Yeah, breathing and speech. Breathing and speech, anyone? Abigail Usher.
This is the cardiac muscle.
How does the cardiac muscle help in breathing? Third person, Abigail.
Madam, please.
How does cardiac muscle help in breathing? Abigail.
Hello. Hello.
Yes, who is speaking? Okay, so William, breathing and speech.
For breathing and speech, I think it's still the smooth muscle.
Yes, it's still the smooth muscle. Blood circulation. Osei Martin, your hand is down. Solomon, Akapus. Solomon.
Yes,
Blood
madam.
circulation.
It's the cardiac muscle.
Yes, so you can talk of the cardiac muscle related to the heart pumping blood. You can talk of smooth muscles when blood vessels circulating blood. Then source of body heat, Daniel.
Skeletal muscles.
Yeah, skeletal muscle. So all these muscle tissues function to help the whole body perform their normal functions. Okay. So to use a diagram to better explain, we are saying the cardiac muscle tissue makes up the heart organ, okay? And it's only found in the heart, or it only makes up the heart tissues, not any other parts. And it involves involuntary control. Involuntary control. How do you understand involuntary control, and how does the cardiac muscle tissue perform involuntary activities? Yes. Adobila Agaya. Right. Did I get it right?
Yeah.
Yes, so Adobila, yes, can we hear you? Why is it that the cardiac muscle undergoes involuntary activities?
Madam, I think it's because the involuntary activities is not controlled by the brain. There are things that come of its own, so the cardiac muscle is hardly to be controlled.
Wow, okay. Well, I won't take that. Actually, all systems are controlled by the nervous system. All systems are controlled by the nervous system. Although the heart has a mechanism to start its activity, but the nervous system also controls how fast or slow your heart beats. Nervous system controls all activities, whether voluntary or involuntary. So how does the cardiac muscle tissue perform involuntary activities? Again, Alberta.
I think it is controlled by the autonomic nervous system.
Okay. Autonomic nervous system. I get it. But let's calm down. Let's calm down. How do you understand involuntary activities? Winifred.
Yes, madam. So involuntary activity is you not having physical control over the activity that is being performed.
Yes, basically that's what I mean. So you are not conscious of that activity. You can't control it physically. Okay. So as I said, the nervous system controls all systems, but the involuntary activities, you as an individual, you have no physical control over it. Okay. Then we are also saying that the skeletal muscle tissue undergoes voluntary activities. So how do you also understand voluntary activities? Gideon of Fair.
Please, with the voluntary activities, as you said, for the involuntary, we don't have control by it. With the voluntary, we have control. For instance, before you, with the upper limbs, you have to move it before it will move.
Exactly. Yeah, that's perfect. So you have control over that activity or the work of that tissue. Okay, so contraction is happening at the basic level, but you have to decide to move your arm before it moves. You have physical control, or you are conscious of that activity. Then we also have smooth muscle tissue, and we are saying smooth muscle tissue undergoes involuntary control. Yes, any example to cite this? Any example? Winifred, your hand is still up. Winifred.
So with the smooth muscle, an example is the digestion.
I barely hear you. I can't hear you clearly.
Hello.
Yes.
So I was saying that with the smooth muscle, we talk about digestion.
We talk about what?
When it comes to the
digestion. Okay. Yes.
You don't have any physical control over how digestion takes place in the body.
Yeah. So after eating, you can't decide to halt digestion at a point in time. or to speed up digestion and all that. All that is under the control of the nervous system, yes, but you are not conscious of such activity. Yes, someone is also citing an example, peristalsis movement. So after eating, you don't decide that the food should move upward or downward. By gravity and the control, the nervous control of the esophagus, we have a movement of food down the esophagus. So you can't decide to pause or to stop swallowing at some point. Swallowing, we have the conscious phase.
Tortoise.
So with digestion, with swallowing, we have the oral phase. So with the oral phase, yes, it's a voluntary activity. You consciously swallow. But when it gets to the esophageal phase, at that point, you have no control over it. Hey, you guys are good, okay. And please, I forgot to mention this as well. Okay, I've not conducted one for the CODeL students, but this time around we'll have a presentation on a particular topic in groups, maximum 4. So I would work on the topics and then post it to you on your page. You prepare a presentation on it, then we all learn from your research that you do. I can see that you know a lot from the chat. You are doing well. Okay. Then the last one is the nervous system. The nervous tissue made of nerve cells or the neurons. And we also have the glial cells or the neuroglia cells that are supporting cells to the neurons. And we are saying the nerve tissue is specialized to detect and respond to certain stimuli. Okay, so whenever there's a change in any part of the body, we have these nerves picking up the change in stimuli and then sending it to a particular point where maybe the brain or the spinal cord, interpretation happening and a response coming back to that part of the body for a particular activity to occur. And we are saying glial cells are supporting cells. They support the neurons to perform their functions well by protecting them, by insulating them, by nourishing them. Then we're also saying that looking at I gave you a brief structure of the nerve cell. So I mentioned the dendrites. The dendrites pick up the change or the stimuli, or it picks up the information, okay? Then it will transmit this change or impulse to the cell body. And the cell body also transmits the impulse to the axon. Then the axon also transmits it to the axon terminal. Then we are going to also look at how we're also going to look at how information will move from the axon terminal to another neuron. Now, with the nervous tissues, we will talk of the nervous tissues in the central nervous system. We talk of the nervous tissues in the peripheral nervous system. Now, aside that, we mentioned that we have glial cells. An example of the glial cell in the central nervous system is the oligodendrocyte, functioning to insulate the neurons. So it insulates the neurons in the central nervous system. Then we also have the Schwann cell as a glial cell in the peripheral nervous system, insulating neurons. Now, let's take this as a reading assignment. You will do an oral discussion before the start of next week's class. Now, explaining how glial cells insulate neurons. You can use any of these examples to better explain. Explain how oligodendrocyte or Schwann cell, or in general, glial cells insulate neurons. Please read in details.
Madam, please,
Yes.
the question again, please repeat it for us.
Okay.
Insulate.
So explain how glial cells insulate neurons. Right. So I've just
All right, thank you.
said a summary or something very brief about it, but I want details of what happens and how it happens. Then look at the organ level. With the organ level, we can have a lot of organs that make up a system. The one that you can use, for example, is the stomach as an organ. So with the stomach, we have tissue. Yeah.
Madam, please, we didn't get a question.
So the question is, explain how glial cells insulate
Americans, any question?
neurons.
Americans.
Yeah, no, please.
No, please. So,
are we okay?
In the absence of any further question, discussion, suggestion, then I'll move this lecture to an end.
Yeah,
and
so
then
someone
meet
can just
next
type
time.
in a question.
Thank you very much for your participation.
Those who are still not getting it. So we can pick an organ. Then we are saying we have the epithelial tissue lining the stomach. So that's the pelvic tissue lining the stomach. Then you have the connective tissue. Then you have the muscle tissue, and finally the nervous tissue. So these four tissues come together to form the stomach as an organ. Now take the second reading assignment. Second reading assignment. Okay, so list the tissues that form the following organs. List the tissues that form the following organs. The brain, the liver, and then the kidney. The brain, the liver, and the kidney. List the tissues that form the brain, the liver, and the kidneys. So the organ systems, we have 11 of them. We are going to take them one after the other, study in details how that system functions. So basically, we are going to start with the nervous system, because that is the system that controls all other systems. So you look at the nervous system and how it functions. Then we move to the skeletal system. So the skeletal system is next. After the skeletal system, we look at cardiovascular system. The cardiovascular system, we move to the respiratory system. After the respiratory system, we move to the digestive system. After digestive system, we come to the urinary system. After urinary system, we come to reproductive. After reproductive, we come to integumentary system. If there's still time, we look at endocrine, lymphatic, and then muscular system. So we are going to move in that order. So we are saying the systems are integrated. Integrated meaning if there is a malfunction of one, it affects another system. So here we are saying, for example, when you take in air, we're focusing on oxygen content. Oxygen diffuses into the blood, moving into the cardiovascular circulatory system. Now, the cardiovascular circulatory system will circulate this oxygen to all parts of the body, to all cells of the body. Then we also say that this same blood will travel to the digestive system, pick up nutrients at the end of digestion, circulate the nutrient to all parts of the body. Now, this same blood gets to the kidneys where the blood is filtered, taking out waste products, excess water, excess ions, all substances that the body doesn't need, out as urine. Then we have this same blood circulating to the reproductive system, where the blood may contain some hormones that would help in reproduction. Then you can also say that blood circulation will take some ions, for example, calcium, to the muscular cells, and that will help with contraction and therefore limb movement or body movement. This same blood is transported to the nervous system, mainly the brain, the spinal cord, where it supplies them with nourishment, it supplies them with nutrients and others. And we're also saying that this same circulation supplies the endocrine system with what they need. It also picks up hormones and other secretions back into the blood to all parts of the body where they are needed. Body fluid compartments. Any question on the first introductory part? Any question on the first introductory part? Yes, Solomon, your hand is still up. Any question?
No, please. I don't have any question.
Okay, please kindly put down your hand. And Gideon, your hand is up.
Please, some of us were trying to join the pharmacology class instead of the physiology class, so we couldn't join from the beginning. So if you can kindly brush over the beginning, it will really help us.
Class reps, I think
Yes, madam.
Yes,
Dr. Ya communicated to you, I think, over an hour before the start that you'll be having physiology. So how come your people are not aware?
Please, we actually posted it on the page. It was on the general page.
Okay. So from henceforth, let's kindly pay attention to the page. Okay. Let's pay attention to the page now and then, because that's where you get information. You get information from. So okay. for the sake of Gideon and those who joined in late, I'll send the recording to you after the class so that you can listen to the introductory part, the first part. Gideon, is that okay?
Yes, please. Yes, please. God bless.
Okay.
In fact, you are such a darling.
Thank you. So if there are no questions, I think 441. Let me see. Yes, Salome. Okay. So I can do a little bit of news. Yes, good evening.
Please, with the smooth muscles, no?
Yeah.
You made mention of it being involuntary.
Yeah.
And I wanted to know, is it only involuntary or some aspect of it can be voluntary?
No. All smooth muscles undergo involuntary activities.
Okay, you listed some parts of the body, and we were like identifying which part of the muscle controls them, and we made mention of the breathing and then the speech to be smooth muscles.
Yeah.
But if I don't know if breathing and speech, it can be voluntary to all.
How? You stopping, you ceasing breathing for some few seconds.
Minute. Yes, and divers can stop breathing for like I think some minutes.
Okay, so those are exceptional cases, and that is also under the control of the nervous system, part of the nervous system of which we look at. But when you are talking of the muscle that make up the organ, okay, so for the lungs, we have smooth muscles that make up the lungs. Okay, and we move to the basic level. We look at the cells that make up the smooth muscles. And what is happening at the base, the cell level, the tissue level, you are not aware of. You get it? So we have contraction going to happen. Contraction happening for you to be able to breathe in, breathe out. You are not aware of that activity. I hope you get it. So it's not the whole activity that you are talking of, but what happens before you're able to perform the activity is what you are looking at. For example, if you are to take the heart, okay, we are saying the heart undergoes involuntary activities. Now, the involuntary activities of the cardiac muscle, we are looking at how it's able to pump. Okay, it's able to pump. You are not aware, or you are not conscious, or you are not in control of how the heart pumps. You get it? Yes. Although you have nervous system coming into play to control how high, how faster or slower your heart rate will be. The basic is how the heart pumps, you are not conscious of.
Okay, madam.
Yeah.
Thank you.
You're welcome. Any other questions? Okay, so let's do some 3 slides, then we end. Body fluid compartment. Yes. Is it Rahimatu? Rahinatu?
Yes. Hello, madam.
Yes.
Please, as part of the cell, you made mention of the specialized cells that have a specific function and is unique.
Yeah.
But you mentioned something about the generalized cells. I was confused. Was it the one inside the structure of the cell? I didn't get that part very well. The generalized cells.
Okay.
Thank you.
So the generalized cell is this. Are you talking of this? Can you see the slide?
Yes.
Yes, the whole thing is a generalized cell.
Okay, my network was interrupted, so I couldn't get the generalized cells very well.
Okay, so we are saying the generalized cell is basically found in every part of the body. That makes up the tissues, our tissues and our organs mainly. Okay, and they have the general state of the cell that you know of. You have the organelles, the nucleus, mitochondria, all those found in the cytoplasm. I am sure you are aware of all these. Okay, so that's the generalized cell.
Okay.
But when you talk of the specialized cell, we have some other additional parts, or we have some exemptions from the generalized cell that these ones we don't have, and they are performing a unique function.
Okay.
Yeah.
I've gotten it now. Thank you so much, madam.
You're welcome. Okay. Any other? No other? Body fluids. So, can anyone explain fluid? Fluid. Any idea what a fluid is? Any idea? A fluid. Yes, Gideon.
Please, a fluid can be anything liquid or gaseous.
Anything liquid or gaseous. Okay. Okay. Any other submission? Gideon, kindly mute your microphone when you are done. All right, Emmanuel.
Hello.
Thank you. Is any substance that has no fixed shape?
No fixed shape.
Yes, and can easily move.
Can easily move.
Under pressure.
Okay. 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 So yes, you are giving me different definitions. Physiologically, what's a fluid?
It's substance. It's substance that carries soluble component.
Soluble components.
Yes, for the functions
Okay.
of other cells.
All right. I think I'll take that. Any other submission? Zidepo, Ehiapo, right? Did I get it, darling?
Sister is Ahiable Jidefu.
Ahiable, okay, okay, Ahiable.
Yeah,
Yes.
to add to what my colleagues have just said, what I'll add is when we talk about fluid, we should also think about something that can be able to flow easily.
Okay.
Yeah, and occupy
right.
spaces. Yeah, thank you.
Okay, oh, you're welcome. Last submission, Hayford, watching. Hayford.
Okay, so with the fluid, the physiology of this fluid can also be found in the intracellular compartment of a body or the extracellular compartment of a body, that is outside the skin. So fluid can be found there, and there are fluid that can also be seen in the body. That is the extracellular compartment of a body.
Okay, so that's fine. Hayford is giving us the categories of fluid you have in the body. So basically, I wanted to hear fluid is just water plus dissolved substance. That's all. So we are referring to water or any liquid with dissolved substances. Kindly lower your hands and let's continue. Okay, so when you talk of body fluids, meaning we are looking at the fluid or water plus dissolved substances. And we are saying that the human body is largely made of water. Okay, and at birth, water constitutes approximately 73% of body weight. Okay, so is that high? But when you are growing, it reduces. So you are saying in an average 70 kilogram healthy young adult, the total body water of that person is 60% of the body weight, meaning it's lesser than at birth. So whatever you weigh, 60% of that will give you your total body water. And we have some other factors aside age, such as gender and degree of obesity, that all contribute to different total body water in individuals. Let's take this as a third reading assignment. Third reading assignment. Third reading assignment. So explain the difference in total body water between males and females. Explain the difference in total body water between males and females. So look at the factors that influences body water in males, in females. Which of these two have higher body water? Why? Okay, so please don't go and read shallow information, just go in details. Don't read on just one point. We have a lot of factors that influences differences in body water in males and females. Yes, some Ebenezer, some.
Please, with the assignment that you have been giving us, this, are we to present it in a PDF form or?
No, we discussed it in class. So when we come next week, I just call out some people to discuss or share ideas on what they found. Okay. So it's an oral discussion in class.
Okay. Okay, thank you.
You're welcome. So age I've explained already. Degree of obesity. I think this one will also have a factor in gender. So after discussing the gender, you have degree of obesity in some way in there. Body fluid compartments, as someone just said, we have two main body fluid compartments. We have the fluid inside the cells called the intracellular fluid. The fluid outside the cells called extracellular fluid. It's that simple. So within the cells, we have the fluid part. I mentioned that is the cytosol. The cytosol. So that is an intracellular compartment. And outside the cells, you can have fluids different types of fluids. So all fluids outside the cells are classified as extracellular fluid. Now, so you can see from the chart here, so intracellular makes up a majority of the body fluid. It's 2/3 of the total body water, 2/3. And then 1/3 is extracellular fluid. Now with extracellular fluid, you can talk of interstitial fluid. Interstitial fluid is the fluid that lies right outside the cells, surrounding the cells, close to the cells. Those are interstitial fluids. Then aside interstitial fluid, you can also look at blood plasma, the fluid part of blood. That's also fluid, and it also forms part of the extracellular fluid. Aside these two, you can also have transcellular fluid. Transcellular fluid, you are saying, is the other types of fluid that is found, for example, in the cerebrospinal fluid and any other fluid found in the pleural cavity between the visceral and then the parietal pleura of the lungs. Okay, so all these small cavities within the body, we have some fluids, and all those fluids fall under transcellular fluid. So we end here for today. We continue with the components of this fluid next week for CODeL. Any questions? Yes, Winifred.
Okay, madam, please, I want to ask if we'll be having all the recordings of all the subsequent lectures.
No, it's not all. You can't have all. And even with this, the first one, it's because some of you missed the earlier part. That's why I'm sending it. Because subsequently I've been sending it, and I don't know. I don't want to bring that issue here. So I'll try to help you, but it's not all that you can get. So make sure you're always in class.
But madam, please, can you also, thank you, but please, will you be giving us the slides?
Yeah, the slides, you get them right after here. I'll send them. Yes. Send them to your classroom. Yeah. Yes. Who else? No other submission, contribution.
Madam, please, some of us, our videos are off. So we want to answer questions, but when you raise up your hand, you will not see. So please check on that.
Okay, I'll do that. But I try to, when you raise up your hand, I see. So I call out your names. So I don't know how some of you, yours wasn't showing. So I'll check on that as you move on.
Okay. Thank you.
Any other? Yes, Albert.
Hello, sister. Good evening.
Good evening.
Please, can you go over the smooth muscle tissue for me? You said it performs involuntary activities. So I want to know, let's say I'm eating and the digestive system have a smooth muscle. So let's say if I'm eating, I'm putting food in my mouth and I'm chewing it. With that one, I can control when to swallow it and when not to swallow it. So I'm a little bit confused because you said it's the smooth muscles perform involuntary activities. So can you go further or explain it further to me, please?
Okay. So with the smooth muscles, we mentioned where they are. Someone said peristalsis. Peristalsis happen in the esophagus. Okay. And when I was explaining that, I said for swallowing, we have a swallowing reflex. Okay. So swallowing reflex, we have the portion where you are able to control the voluntary aspect. That is when you are swallowing from the oral. So you have the oral phase where you consciously swallow, you decide to swallow or not. That is not under involuntary activity. But when you swallow it and it gets to the esophagus, now the esophagus is made of smooth tissue or smooth muscle tissue. Okay. So what those muscle tissues are going to do, you can't control it because they are going to contract without your knowledge. They are going to contract, and then that contraction would enable movement of food down the stomach. So the swallowing, if you talk of swallowing, we have swallowing reflex. We have the oral phase, the pharyngeal phase, and then the esophageal. So the oral and then the oral phase is consciously, voluntarily, you decide to swallow. So when it gets to the pharyngeal phase, that's where the involuntary aspect takes place. And that's as a result of the muscles that make up the esophagus and the pharynx are all smooth muscles. I don't know if I'm clear.
Yes, thank you.
Yeah. Yes. Adoliba. Yes.
Madam, please, I want to make some, want to appeal on something with the reference of the quizzes you talked of, the unannounced quizzes and those stuff.
Okay.
Some of us where we are, the network is very, sometimes you log in, you try joining a whole lot of times. Before you move around now. So with that, in case it's time for this kind of unexpected quiz and one is trying hard not to, to get inside and it's not, without way, it's going to be something else for some of us. Some have to travel to a different place just to get a better network.
Okay. All right. So.
And that is it.
Yeah. So you're appealing well here.
Serious water.
Yeah. I get it now. So let's do it this way. Okay. So if, for example, you have a quiz today during class, even with that one, I don't know how it's going to help you, but I can tell you ahead of time. Okay. Just that the quiz, I will give a particular duration. Okay, and even after that, I'm sure a lot of you come and tell me they couldn't do it and all that. I can give you, for example, an hour, okay, to log onto that particular platform and do the quiz. You get it? And so make sure you have your email with your password intact so that when it gets there, you are not going to tell me you can't log in because you forgot your password or I don't know. So please just be ready for anything, but I'll try and let you know ahead of time.
Okay.
And also I'll give you a duration to do it so that when the time is up, that's it. I hope it's better. It's better than the first.
Yeah, it's better now. Thank you.
All right. Then William, my time is up.
Yeah. Hello.
Yes.
Yeah, so mine is not a question, mine is actually a contribution with regards to the voluntary and the involuntary aspect.
Okay.
So like you explained earlier, we have exceptions when it comes to the voluntary and the involuntary aspect. For example, with a skeletal muscle, it's voluntary, but in some cases, such as when you have the twitching of the face, or you have the trembling of the hand, it moves without you controlling it. So we have exceptions. So I want my colleagues to understand that they are going to actually look at the little exceptions to actually classify some of the muscles as involuntary or involuntary. Then it's going to be a problem because we have people who can actually put food in their stomach and bring it back into their mouth.
Yeah, I heard of that.
Yes, it doesn't mean that it is natural that the smooth muscles in the esophagus or in the digestive tract is voluntary. It's just an exception. So that's what I wanted to add.
That's it. Yes, that's it. well said. So I hope the class is clear. So what that we are saying, we are looking at the generalized view, okay, but there can always be exceptions to what we are doing. All right. Dinah.
Yeah, good evening.
Good evening.
Please, I wanted to find out with the transcellular fluids you said, will we classify them under the extracellular fluids or they are just different?
Transcellular fluids are under extracellular fluids.
Okay. Okay, thank you.
You're welcome. Eric, also.
Madam, good afternoon. Good evening.
Good evening.
I want to find out about the format for your quizzes. Is it going to be objectives or is it going to be objectives and written? I want to know.
Quizzes are in written format. Brief explanation. It's going to be online, so I'll provide a space. You just type in what you know, then you submit.
Okay. Okay.
Are you clear?
Yeah, and what of the midterms and end of semester?
We have not gotten there. When we get there, I'll let you know.
Yeah. Okay, thank you very much.
You're welcome.
Sister Isahia, you are trying. Thank you.
Hey,
I'm sorry. I have to blame my father for that. Please, mine is not about what we are learning right now, but it's just that during our orientation, they talk about some laptops which are available in the school. And I asked the last time that I was told they'll check up on it and get us feedback, but so now I've not heard anything. So I just want you to help us get more information about it and how we can get hold of it and the payment process.
All right, so some are available. You contact the director directly, okay, for more details.
Oh, okay.
So ask the class rep to do that for you if you don't have his contacts.
Oh, okay.
Yes.
Hello, madam.
Then, yes.
Please, good evening.
Good evening.
Please, the SIM, how can we get it? Because we in Accra, how are we going to get the SIM?
So most of the times, the souvenirs and other things that you have to get, we bring them at the end of the first semester when we are coming for vigilation. Okay. When we are coming for vigilation at the centers.
Okay. Thank you.
So yes.
Then please, what about handouts or
handouts? Handouts, physiology, I don't have a handout for you. So with the slides, the recordings, and then the textbooks I've suggested, videos, it should help you out.
Please, how are we going to get
handouts? If you have any handouts, you can also use it.
Okay. Thank you.
You're welcome. All right. So thank you very much. It was I guess it was a fruitful class. And we hope to meet again next week, God willing. All right. Have a good evening.
Good evening.
Thank you very much. Thank you.
Thank you.
Thank you.